Today, no one can think of a world without travel. We travel day in and day out. Every day, we commute from our homes to the college or the workplace, and from college or office back home. Once in a while, we travel long distances to our dream holiday destinations. We travel by bike, cycle, rickshaw, car, bus, train, and planes. In our day to day affairs, we cannot get away from the relationship between time and distance or the concept of speed. In this discussion, we shall set your base clear on these concepts. It would help you in practical real life situations and in solving simple aptitude questions. What we have here is an elementary discussion, refreshing things that you had learned in your school or college days. Welcome to this discussion on time and distance basics. Before we go on to understand the relationship between distance, time, and speed, let us spend some time to look at how they are measured and the various units used to measure them. Many different units of length are in use across the world due to historic and practical reasons. Distances in a sprint track or swimming competitions are expressed in meters. We have the 100-meter dash, 200-meter, 400-meter, and 800-meter races. But it will be awkward to express the distance between Delhi and Kochi in meters. We use kilometers there. If you ask an American the distance between New York and Chicago, she will tell the distance in miles, which is the commonly used unit of distance in that part of the world. You might have heard some elderly people mentioning a short distance in terms of furlongs. A furlong is 1/8 of a mile. Another unit of distance used especially by navigators in shipping and aviation industries is the nautical mile, which is a unit of distance that takes the curvature of Earth into consideration. A carpenter, or for that matter, anyone related to the construction industry, is likely to measure distances in terms of inches and feet. The standard length of a cricket pitch is 22 yards. Yard is yet another unit of measuring distance. The distance between celestial objects, distance between stars, distance between the sun and the earth, etc., are measured in light years or light minutes. At the lower level, the length of a kidney stone is indicated in millimeters. The length of your classroom scale is expressed in centimeters. The most commonly used units of distance in time and distance situations are meters and kilometers. Many a time, you would be required to know the conversion between these units. Now refer to the question given in the slide. Can you say which is longer? A standard cricket pitch or a 100-meter track? And by how much? The cricket pitch is usually measured in terms of yards. The length of a cricket pitch is 22 yards. Which is bigger? 22 yards or 100 meters? If you want to compare these two, as of now, it is like comparing apples and oranges. They are not in the same unit. We need to convert both of them either into yards or into meters. Let us convert the 22 yards into meters. You can see that 1 yard is 3 feet and 1 feet is 0.3 meters. So 22 yards will be 22 into 3 into 0.3 or approximately 20 meters. So a cricket pitch is 1/5 of a 100-meter track. So when Sachin runs for a run, the distance that he runs is roughly 1/5 of what Usain Bolt runs in a 100-meter dash. In Q1, we are asked to convert the height given in centimeters into feet and inches. Both these units are commonly used to represent height of individuals. The height given here is 190.5 centimeters. 190.5 centimeters will be 190.5 by 2.54 or 75 inches. Now let us see how many feet this will be equal to. 1 foot equals 12 inches. 75 inches will be 75 by 12, which is 6.25 feet or 6 feet and 3 inches. In question Q2, the waist size is given in inches. 30 inches equal to 30 into 2.54 centimeters or 76.2 centimeters. In Q3, the distance is given in miles. In many parts of the world, distances are expressed in miles. The relationship between miles and kilometers is 5 miles equals 8 kilometers. So 700 miles equals 700 into 8 by 5 or 1120 kilometers. Now let us look at the units of time. Unlike the distance, which has different base units because of historic, geographic, and practical reasons, time has the same base unit across the world. It is the second. Other commonly used units, be it the minute, the hour, or the day, they are all aggregations of the base unit second. On the lower side, we have milliseconds, microseconds, nanoseconds, etc., which are the second divided into parts. Now that we have gone through the base units of distance and time, we are ready to look at the units of speed. Before that, what is speed? At the base level, we can say that speed is the rate of doing something with respect to time. From our discussion point of view, speed is the rate at which distance is covered or traversed with respect to time. Let us say the distance between your house and college is 40 kilometers. And let us assume that you take a certain time to cover this distance every day. Now, if on a particular day you took less time to cover the distance, then you would say that your speed was higher than usual. If you took more time to cover the distance, you would say that your speed was lower than usual. If you want to quantify speed into a number, since speed is the rate at which distance is covered with respect to time, speed equals distance by time. Let us assume that you usually take 1 hour to cover the 40-kilometer distance from your house to the college. Then your speed is distance divided by time, or 40 kilometers divided by 1 hour, or 40 kilometers per hour. As the distance was expressed in kilometers and the time was expressed in hours, the speed is obtained in kilometer per hour. If you had expressed the distance in meters and time in seconds, you would get the speed in meters per second. Like kilometer per hour, meters per second is another commonly used unit for expressing speed. The conversion from one unit to the other is given in the slide. 1 kilometer per hour is 5 by 18 meter per second, and 1 meter per second is 18 by 5 kilometers per hour. These relationships can be obtained by substituting 1 kilometer equals 1000 meters and 1 hour equals 3600 seconds. Let us take a relook at the previously discussed situation. You traveled 40 kilometers in 1 hour and said that your speed was 40 kilometers per hour. Now, what speed was that? If you look from a practical angle, if you were traveling by your bike, does it mean that you traveled the entire distance at the same speed of 40 kilometers per hour? Or that you traveled the entire 1 hour at 40 kilometers per hour? Even though it is a possible scenario under ideal conditions, from a practical perspective, you and I know that it would be impossible to maintain a particular speed for long durations in our roads due to traffic, signals, bad roads, etc. So what does this 40 km per hour that we had found out really indicate? It indicates the average speed of your journey. By definition, average speed of a journey is total distance by the total time. When you are traveling at a constant speed, that is, you maintain the same speed throughout the journey, then your speed at any moment will be the same as the average speed found out this way. Constant speed situations are to a large extent possible in rail journeys and air travel. In aptitude questions, we usually assume the speed to be constant to make the situation a little less complex. When we travel in a bike or a car, very often we look at the speedometer to see how fast we are moving. What does the speedometer show? Let us say the speedometer shows 70 km per hour as the speed. What does that 70 km per hour mean? It means that if we were to travel for 1 hour at the speed at which we are traveling at the moment, we would cover a distance of 70 kilometers in that 1 hour. Let us look at some simple questions to test what we have learned till now. Anil travels 50 kilometers in 2 hours. What is his speed? What speed is it? Speed equals distance by time equals 50 kilometers by 2 hours or 25 kilometers per hour. Now, we do not know whether Anil traveled the entire 2 hours at the same speed or not. If he had traveled at the same speed throughout the time, then 25 kilometers per hour that we got represents the constant speed at which he was traveling. In the absence of additional information about the nature of his journey, we can safely say that this value 25 km per hour represents the average speed. In the case of constant speed journey, the constant speed will be the same as average speed. Now, one thing you can assume while doing questions from this set is that unless otherwise specified, the speed remains constant during the time under consideration. This will make a lot of our calculations simple. Teresa travels 35 kilometers in 20 minutes and Rachel travels 150 kilometers in 1.5 hours. Who is faster? Let us look at Teresa first. She travels for 20 minutes. 20 minutes means 20 by 60 or 1 by 3 hours. Let us look at Rachel. She travels 1.5 hours. Now use the relationship between distance and time to compute their speeds. Teresa's speed will be 35 kilometers in 1 by 3 hours or 35 by 1 by 3, which is 105 kilometers per hour. Rachel's speed will be 150 kilometers in 1.5 hours or 150 by 3 by 2, which is 100 kilometers per hour. Thus we can see that Teresa is faster than Rachel. Look at the slide. Franco traveled 20 minutes in his bike at a speed of 60 kilometers per hour. Can you find the distance traveled? We know that Franco's speed is 60 kilometers per hour. That means Franco will travel 60 kilometers in 1 hour. But he has not traveled for 1 hour. He has just traveled for 20 minutes, which is 1 by 3rd of an hour. So in 1 by 3rd time, he will travel 1 by 3rd the distance of 60 kilometers, which is 1 by 3 into 60 or 20 kilometers. Looking from another angle, speed equals distance by time. So distance equal to speed into time. Here, speed equals 60 kilometers per hour, time equals 20 minutes or 1 by 3 hours. So distance equal to 60 into 1 by 3 or 20 kilometers. Try this question. The train Mangla Express travels 75 kilometers at a speed of 90 kilometers per hour. What is the time taken for covering the distance? Here, out of the 3 parameters speed, distance and time, we know the speed and the distance. So we can find out the value of time. We know that speed equals distance by time. So time equals distance by speed. In this case, it comes as 75 kilometers by 90 kilometers per hour, or 5 by 6 hours, which is 50 minutes. The three relationships that you will frequently use to answer questions from time and distance are speed equals distance by time, distance equals speed into time, and time equals distance by speed. Note that all these relationships have come from the basic definition of speed as distance by time. Now that you have understood the basic relationships between speed, distance, and time, you are ready to understand the nuances of these relationships. When speed is a constant, distance and time would be directly proportional. Let us try to understand this a bit more clearly, looking at the case of Miss Gauri, who jogs at constant speed of 2 meters per second for 10 minutes. Here it is mentioned that Gauri's speed remains constant for the 10 minutes time, and the speed is 2 meters per second. If you observe the distance that she covers over the period of time, every second she covers 2 meters. That is what we mean when we say that her speed is 2 meters per second, isn't it? So in the first second, she covers 2 meters. In the second second also, she covers 2 meters. So in 2 seconds, she covers 2 plus 2 or 4 meters. In the third second, she covers 2 meters again. So in the first 3 seconds, she covers 2 plus 2 plus 2 or 6 meters. In the fourth second, she again jogs 2 meters. So in 4 seconds, she covers 6 plus 2 or 8 meters and so on. So the distances covered in 1, 2, 3, 4 and 5 seconds are 2, 4, 6, 8 and 10 meters. So we see that the distance and time are directly proportional here. That is, when one of the variable, distance or time, increases, the other automatically increases proportionately. Thus, at constant speed, in more time you travel more distance, in less time you travel less distance. When distance is constant, speed and time are inversely proportional. Let us imagine that you are running along an 800-meter track. You are running at a speed of 1 meter per second, let us say. How much time will you take? The distance to be covered is 800 meters. You are covering 1 meter every second. So you will require 800 seconds to cover the distance. When the speed is 1, time is 800. Now if you run this 800 meters at 2 meter per second speed, then the time taken will be distance by speed 800 by 2 or 400 seconds. So when speed is 2, time is 400. If you run this 800 meters at 4 meter per second speed, then time taken will be distance by speed 800 by 4 or 200 seconds. So when speed is 4, time is 200. If you run this 800 meter at 8 meter per second speed, then the time taken will be 800 by 8 or 100 seconds. So when speed is 8, time is 100. Here we find that when the speed is increased, time taken decreases. Moreover, when the speed is doubled, time is halved and so on. This kind of relationship is what we call an inverse relationship. Thus, when distance is a constant or same, speed and time have an inverse relationship. When time is a constant, distance and speed would be directly proportional. Let us imagine a situation where a car, a bus, and a rickshaw are moving along a highway at their maximum speeds and they are maintaining that speed. It is given that maximum speed of the car equals 60 km per hour. Maximum speed of the bus equals 40 km per hour. Maximum speed of the rickshaw is 20 kilometers per hour. Let us just observe what happens with the passage of time. Let us see the distances travelled after an hour. In 1 hour, the car travels 60 kilometers. This is obtained as distance equal to speed into time, or 60 into 1 hour, so 60. Bus travels 40 into 1, 40 kilometers. Rickshaw travels 20 into 1 or 20 kilometers. Observe what happens after 2 hours. Distance travelled by the car equal to speed into time equal to 60 kilometers per hour into 2 hours or 120 kilometers. Distance travelled by the bus will be 40 into 2 or 80 kilometers. Distance travelled by the rickshaw will be 20 into 2 or 40 kilometers. After 3 hours, the distances travelled by the car, bus and rickshaw will be 180, 120 and 60 kilometers respectively. We can observe that in any given time, the vehicle with the larger speed travels larger distance. If you observe the distance travelled by the three vehicles closely, we see that after first hour, the distances are car 60, bus 40 and rickshaw 20. And the distances travelled by the vehicles are always in the ratio of their speeds. The distances travelled by the vehicles in 2 hours are 120, 80 and 40 kilometers. Again, the ratio is 60 is to 40 is to 20, the ratio of the speeds. The more the speed, the larger the distance covered in the same time. Thus, we can see that when time is a constant, distance and speed are directly proportional. In all the situations discussed above, speed was taken as uniform speed. That is, it did not change within the given time interval. However, in practice, it is usually a rare occurrence. Can you remember the last time you traveled a 5-kilometer stretch at uniform speed? Probably no. In practical situations, the speed keeps changing during the course of a journey. How do we approach such situations? Here, we use the concept of average speed. Let us look at a question to understand the concept of average speed a bit more closely. Here, the car was traveling at different speeds at different times during the journey. At the bad patch, Zubin would have traveled at less than 20 kilometers per hour, and at the freeway, he would have cruised at 80 kilometers per hour. He would have waited at the signals for some time. In such cases, average speed is the best indicator of the rate at which the total distance is covered. Average speed is defined as total distance by total time. Here, it is immaterial what the speed was at different parts of the journey. What matters is that it took 90 minutes for Zubin to travel the distance of 60 kilometers. So his average speed for the journey will be 60 kilometers in 90 minutes, or 60 kilometers by 1.5 hours, or 40 kilometers per hour. Note that we converted the unit of time in minutes to hours to get the speed in more common unit, kilometers per hour. In situations where speed varies during the course of journey, average speed is the best indicator of the overall speed during the journey. It is that speed which, if the body had maintained throughout the journey, it would cover the total distance in the given time. During this discussion, we looked at units of distance, time, and speed. We understood the basic relationship between speed, distance, and time, which is speed equals distance by time and its derivatives. We looked at the nuances of each of those relationships, and finally, we looked at the concept of average speed. What we discussed here were all elementary but fundamental concepts of time and distance. Be thorough on the fundamentals. Thank you.